Good morning, my dear students. Today we are going to discussing about coagulation. Okay, so generally coagulation also called as a precipitation. Coagulation or precipitation. So actually, what is the coagulation or what is the precipitation? We'll see. See here, actually, what happening? Generally, when I am going to talk about the lyophobic soles. Okay, lyophobic soles. Soles. The stability of the lyophobic soles, okay, depend upon, okay, charge on charges. Okay, see, I am writing here lyophobic soles. When I am going to talk about the lyophobic soles, stability, okay, stability of lyophobic soles depends on okay, charge or charges. Okay, because generally in a colloidal solution, in the last class we discussed what you know, generally these are showing the charge. The colloidal soles may be positive charge, there may be negative charged colloidal solutions. Am I right or not? So generally what happening, when I am going to removing charges, when we will remove the charges or charged particles, okay, charges from colloidal solution, okay, or neutralizing. If suppose we are neutralizing the colloidal particles, what happens, sir, actually? Okay, what happens, sir? See, generally the colloidal particles, okay, settled down. What happening here? Particles of colloidal solution, okay, particles of colloidal solution, okay, settled down. How they were? Because what happening? Charge is not there. Okay, so immediately what happening? Precipitation takes place. Okay, so settle down. Okay, how it will be? Particles of the particles of colloidal solution. Okay, settle down. Okay, settle down under gravitational force. Okay, am I right or not? Under influence of gravitational force. Am I right or not? So see, I am writing in this case under force of gravitation. See. So now this phenomena is called as, I am writing, this phenomena is called as coagulation or precipitation. This phenomena is called as coagulation or precipitation. Okay, are you getting my point? Precipitation. See, now once again I am explaining what I am telling you. Stability of lyophobic sole depends on charges. Okay, so lyophobic soles are stabilized by the charges only. So when we will remove the charges from the colloidal solution, otherwise I am neutralizing. I am adding, for example, it is a negative sole. Okay, for example, one negative sole is there. I am adding positive particles. Then it becomes neutralized. When it becomes neutralized, or when we are going to removing the whatever it may be charges, okay, particles of the colloidal solution settle down under force of gravitation. The phenomena settle down under force of gravitation is called coagulation or precipitation. Okay, so to coagulate the lyophobic sole, different ways are there. First one, we know that one. In electrophoresis, what happening? The movement of charged particles takes place or colloidal particles takes place. In that case, what happening? Precipitation takes place. Is it right or not? Okay, so some negative charged particles moves towards the positive electrode, and positive particles are moving towards the negative electrode. Is it right or not? Then movement takes place means what happening? There whatever it may be, deposition takes place. Deposition takes place means what happens? Precipitation. So electrophoresis. Okay, different methods are there. First, coagulation takes place by applying the electrophoresis. Okay, electrophoresis. We are using this method, forces. Okay, second, I am going to talk about second one by boiling. Okay, second, by boiling the colloidal, okay, boiling the colloidal solution, then okay, colloidal particles may crystallized. And in the case of dialysis, okay, which dialysis, sir? Continuously dialysis we are doing. This is called as a by persistent dialysis. Okay, by persistent dialysis. Persistent dialysis. Okay, these are the methods. Okay, and another method is there, very very important method. So the coagulation takes place by adding the what, sir? Electrolytes. Okay, so addition of electrolyte to the colloidal solution. What happening, sir? Coagulation takes place by addition of. This is the very very important. Okay, we'll discuss this. All those things are normal things, but this is the very very important thing. Whatever it may be, I will tell. That is the, we'll discuss about this one by addition of TiO, by addition of electrolyte. Sir, how it will be effect, sir? By addition of electrolyte. See, if suppose electrolyte has, okay, charged particles, how I will tell. For example, when we are going to, okay, adding in any solution, the electrolyte can dissociate into positive and negative particles. You know that very well. SM right or not? So how the coagulation takes place in this case? For example, any electrolyte I am taking. For example, electrolyte like a NaOH I take, NaOH. When I am adding into water, H2O, okay, then what happening, sir? Na plus OH minus. Okay, am I right or not? This is the means these are carrying the charges, okay, in a solvent. Am I right or not? So in the same manner, when we are going to adding this electrolyte into colloidal solution, then electrolyting containing charged particles can interact with what happening, sir? Colloidal particles, and they may neutralize. If suppose I will tell, see, if suppose I will tell, for example, I am taking, how it is working, sir? For example, I am taking, it is a one of the positive sol. Okay, if suppose this is what, sir? Positive solar colloidal solution. So for example, I am taking Al2, okay, SO4 vacant twice. This is the electrolyte. What is this, sir? This is the electrolyte. Are you getting my point? See, when I am adding this electrolyte to this sol, okay, so aluminum sulfate can, okay, dissociate into Al3 plus, okay, as well as, okay, SO4 2 minus ions. Okay, this is a which sol, sir? Positive sol. Now this SO4 2 minus ions, okay, when they are going to dissociated and these are reacting with this sol, interact with these positive particles, okay, then what happening, sir? This become neutralized. When this become neutralized, means these colloidal particles become neutralized, they may settle down. They may takes, here what takes place, sir? Here precipitation takes place. Are you getting my point? So SO4 2 minus is the ions. Okay, these ions are produced by the electrolyte, emulator nut. Means what is the electrolyte role, sir? Here electrolyte is, okay, in any solvent, electrolyte can dissociate into charged particles. So for example, same electrolyte I am taking. So for example, this is the negative sol. Okay, if suppose this is a negative sol. Are you getting my point? So all negative particles are there. Okay, how the negative sol and how the positive sol is forming, okay, I told you in the last class only. Okay, I clearly explained that thing. So for example, when I am adding Al to SO4, same solution. So but what happening here? Here Al plus 3 ions, okay, here SO4 2 minus ions. In this case, what happening? Al plus 3 ions can react with this negative particles of the colloid, okay, or negative colloidal particles. Then what happening? Neutralization takes place again. Okay, what happening? Coagulation or precipitation, okay, takes place. Are you getting my point? Okay, means these Al plus 3 ions can react with these negative particles, okay, or interact with these negative sol particles, and what happening, sir? Here precipitation or coagulation takes place. Understood? So this is the very important. But here one thing I will tell you. Okay. So the coagulation power of ions. Okay. See, I am writing here. The coagulation power of ions. Okay, ions. So it is depend upon the charge. Okay, so that can decided by power of ions is decided by Hardy-Schulze method or law. It decided by Hardy-Schulze method. Hardy-Schulze law. Are you getting my point? Okay, what is the Hardy-Schulze law, sir, actually? Okay, so here the coagulation power of ions is, see here in the case of Al plus 3 was there, here SO4 2 minus ions are there. So we'll discuss what is the coagulation power. We'll discuss 1 minute. What is the Hardy-Schulze method? Have you understood this one? I hope you understood this one. Hardy So what is the Hardy-Schulze law, sir, or rule? Law or rule? See, law by rule I am writing. Okay. See, what is the Hardy-Schulze law or what is the Hardy-Schulze rule? Okay. See, generally, greater the, I am writing, greater the valence of fluctuating ion. So what is the fluctuating ion, sir? Fluctuating ion. See, when I am adding the electrolyte to the colloidal solution, so precipitation takes place by the electrolyte containing opposite charged particles. Is right or not? So means fluctuating ion is nothing but oppositely charged ion. Okay, opposite charged ion or oppositely charged ion. Are you getting my point? Charged ion. So that's why I am writing in this manner. Or okay, anyone is confused with the fluctuating ion? Okay, I am writing in this manner. Greater the charge by valence. Okay, I am writing greater the charge by charge valence. Okay, greater the charge or valence of oppositely charged ion. Oppositely charged ion. This ion is coming from where, sir? Generally, this ion is coming from the electrolyte. Am I right or not? Opposite charged ion of electrolyte. Would be greater the coagulation or higher the coagulation. We'll write any manner. Greater the coagulation or higher the electrolyte. Higher would be coagulation. Or greater would be coagulation. Higher would be coagulation. Are you getting my point? So means, what is the meaning of this one, sir? For example, if suppose I told you very clearly, you people, when I am adding the electrolyte, okay, so same aluminum sulfate I added to the negative sole as well as the positive sole. Yes, am I right or not? When I am adding the aluminum sulfate to the positive sole, okay, electrolyte containing the sulfate ions, okay, interact with the positive sole particles. Yes, am I right or not? And as well as okay, when I am adding, when I added this aluminum sulfate to the negative sole, okay, the electrolyte containing aluminum Al plus 3 particles can interact with the, they are interactive with the sole particles. Yes, am I right or not? So, but how? Means what is the meaning of this one? Greater means here charge will be greater. So when we are adding the any electrolyte to the colloidal particles, the oppositely charged particles can show, okay, higher charge. Okay, so then immediately coagulation or precipitation takes place. If suppose I will tell you clearly, see, I will take different electrolytes. If suppose I am taking the Al2SO4 vacant piece, this is the one. Okay, same, I am taking the Na3PO4, okay, and I am taking NaCl, okay, NaCl, and I am taking here MgCl2. Are you getting my point? So as well as I am taking the BaCl2. If suppose these are the electrolytes, these are all electrolytes. Okay, see, what is the meaning of this one I will tell. Okay, see, this is a, for example, negative sole. If suppose it is a negative sole, I am clearing here all those things, it is a negative sole. All negative particles are there, negative colloidal particles are there. These are all negative colloidal particles. Yes, am I right or not? So when I am adding Al2SO4, okay, and Na3PO4 and NaCl and as well as MgCl2 as well as BaCl2. Okay, which one takes place? Means while adding which electrolyte, okay, precipitation takes place very fast. That is only explaining through the Hardy-Schulze method. If suppose, okay, I will take different. Now Al2SO4 3, again same negative sole, okay, I am taking in another container. These are the minus particles. Okay, these are all minus particle. This is also negative sole, same sole only. Okay, negative sole. Again I am taking in another beaker also or another container also. See, same, okay, negative sole I am taking. Okay, negative particles are there. This is also negative sole. Now in this case I added Al2SO4 3 electrolyte. I am adding what's an Al2SO4 vacant piece. In this case I am adding, okay, Na3PO4. Okay, in this case I am adding Na3PO4 electrolyte I added. Okay, in this case I am adding BaCl2. Okay, BaCl2. See, what happened? In this case I added the electrolyte BaCl2. In this case I am added the Na3PO4 electrolyte, Al2SO4 electrolyte I added. So in this case, what are the here means is the negative sole. So here electrolyte can dissociate into Al plus 3 SO4 minus. Is right or not? So let it be. Now here which particles will be means comes out from the electrolytes are positive particles, Al plus 3. Here in this case only Na plus particles were there. Here Ba2 plus or Ba plus 2 particles were there. Is right or not? Al3 plus, okay, Na plus Ba2 plus particles. Now, so generally Al is having the higher charge, greater valence. When the greater valence is there, okay, at a time 3 negative particles can precipitated by 1 Al plus 3. Yes, are you getting my point? In this case only in the case of Na, only one negative particle can neutralized by the 1 Na plus. In this case, okay, 2 negative particles, sole particles can neutralized by the 1 Ba2 plus. Means when, okay, the charge is higher or valence is higher, okay, on the opposite ion of the electrolyte. Where it is higher, sir? Opposite ion having the higher charge, then, okay, easily coagulation takes place, very fast takes place. Means in the case of, when I am going to talk about, okay, we are taking the pick up the ions, okay, in the ions, okay, which is the greater, sir, value, which is, okay, higher, means which is, while adding which one, higher coagulation takes place, sir? Al plus 3, means same sole. But what I change here I changed only what, sir? Electrolytes. Okay, in one electrolyte, okay, it is showing the plus 3 oxidation state, it is showing the plus oxidation state, it is showing the plus 2 oxidation state. Means valence is more. So here valence is more, okay, coagulation takes place very fast. Are you getting my point? So in this case, okay, Al plus 3, okay, R, greater then, okay, Ba 2 plus, again MgCl2 I am taking, Mg also having what sir, plus 2, both are having the same, okay. For example, I am taking two negative salt solutions, okay, I added BaCl2 as well as, okay, MgCl2, okay, precipitation takes place same with the, okay, in both cases precipitation takes place same time only, okay. So means both are having the same, not any change, and Na plus, okay. So means in this case which is having the more, means greater value sir, higher valence, means which is, okay, and through, while adding the Al plus 3 what happening sir, so coagulation takes place higher. Are you getting my point? So this is the very very important. So for example, I am taking same thing. So see, it is, you understood this one. Now I am going to take negative source. Okay. See, in this case same, I am taking what sir, Al2SO4. Okay, vacant pi is 3. Okay, Na3PO4 in this case. Okay, same I am going to take. Again, what I am taking sir, NaCl. Okay, BaCl2. Okay, and what I am taking sir here, MgCl2. Are you getting my point? Now here negative ions. Okay, pick up the ions, negative ions. Okay, so PO4, which is our sir, 2 minus. Okay, and SO4, sorry, PO4 3 minus. Sorry, SO4 2 minus. I thought SO4. This is the PO. Okay, SO4 2 minus as well as Cl minus. Now I am taking, for example, 3 positive soles. Okay, positive soles. This is the positive sole solution. So this is also positive sole. Okay, same sole I am taking. Okay, or same colloidal solution I am taking, positive colloidal solution. Now this is also positive solution, SM rate not positive sole. So now I am adding here sodium phosphate. Yes, this is the electrolyte. In the second one I am adding this one. In third one I am adding this one, electrolytes. Are you getting my point? Then in which case coagulation takes place very fast sir? In the case of adding the phosphate. Why? Because here positive charges are there. Okay, when I am adding sodium phosphate, okay, it can dissociate into Na plus as well as PO4 3 minus. Are you getting my point? One phosphate ion can get neutralized the 3 positive charges. So higher the charge, okay, coagulation. Okay, next SO4 2 minus, after that Cl minus. Means how we will write sir? In this case PO4 3 minus is greater than SO4 2 minus. Okay, sorry. Okay, is greater than Cl minus. So this is the Ardeshulje law. Very very easy law. Nothing is there. Okay, flocculating ion. It means the coagulation, okay, depends on the flocculating ion. So the flocculating ion has the higher valency or greater valency. Okay, higher would be the coagulation. Higher would be the coagulation. Are you getting my point? See, generally lyophobic salts. I am going to talk about the lyophobic salts. See, lyophobic salts. These are less stable. SM rate or not, less stable. Okay, already we discussed all those things in the previous classes only. Okay, lyophobic salts are the less stable. Okay, while adding, means we want to stabilize these lyophobic salts. What we are doing sir? We are adding lyophilic salt. Okay, what we are adding? Lyophilic salt. Okay, so when we are adding the lyophilic salt, they may get stabilized. Okay, stability, okay, stability more. See, I am adding less stable. While, okay, adding, I am writing. While adding, okay, lyophilic salt to, okay, lyophobic salt. Lyophobic salt. Stability increases. What happens sir? Stability increases. So this is called as a protection. Okay, what is this sir? This is called as a protection. So it is a property. What I am telling here, it is a property of a lyophilic sole. I am writing here. It is a property of lyophilic sole to stabilize the lyophobic sole. Okay, or what I am telling here, okay, it is a property of lyophilic sole or lyophilic colloid to prevent the precipitation. Okay, to prevent or prevents the precipitation of lyophobic sole. Okay, of lyophobic sole. Lyophobic sole. Okay, is called protection. Yes, am I right or not? Okay, lyophobic sole. Okay, is called or are called protection. Yes, am I right or not? So what happened? What I told you here, see. So stability is increasing. Generally, lyophobic soles are easily precipitates. Okay, they are going to precipitate easily. Why? Because generally affection between the DAP and DM means dispersed phase and dispersion medium is very less, negligible. Okay, negligible. So in that case, simply the particles easily settle down. Am I right or not? Okay, in the case of charged, okay, charged, that is different. But when it is not charged, what happening? Simply they may settle down. Precipitation takes place or coagulation takes place. Okay, we want to prevent from the coagulation or precipitation. That is called as a protection. How we are going to protecting, sir? We are going to protecting by adding the lyophilic soles. So it is a property of lyophilic sole to prevent the PPT or precipitation of lyophobic sole is called protection. Okay, so these are called as a protectors. Okay, what are the protectors, sir? Actually here the protectors are nothing but the lyophilic soles. Now we'll go to the next point. Next, emulsion. What is the emulsion, sir? See, I will talk about the emulsion. It is generally, okay, any colloidal, I am preparing the colloidal solution. Okay, I am preparing colloidal solution. In this colloidal solution, I took the dispersion medium. This is the dispersion medium, I think water or solvent. Okay, water by solvent, I am taking any solvent, liquid. Okay, liquid solvent I am taking. Again, this is what, sir? Solvent means dispersion medium. Okay, this is the dispersion medium. And I am adding any other liquid. Okay, another liquid I am adding as a liquid, as a DP, means dispersed phase. Okay, I am adding another liquid as a dispersed phase. Okay, means in this case, dispersion medium, okay, DM and DP, dispersion phase, both are in liquid state. Yes, am I right or not? Liquid state. See, in any colloidal solution, okay, dispersion phase, dispersion medium as well as, dispersion medium as well as dispersion phase. Dispersion medium as well as dispersed phase, both are in liquid state, are called emulsion. Or is called emulsion. Okay, so in this case I am writing, in this case okay, dispersion medium and dispersed phase, both are in liquid state. Both are in liquid state or liquids. So how it is forming, sir? Generally, so I am taking any liquid. See, in the system, dispersion of finely divided. Okay, in this case what happening? Dispersion of finely divided, Okay, finely divided. What, sir? Here no solid liquid. Okay, finely divided droplets of droplets. Finely divided droplets. Droplets. In another liquid. Okay, divided. See, dispersion of finely divided droplets in another liquid or in other liquid. Okay, takes place. Liquid. So, what happening, sir, here? Dispersion of. Okay, dispersion takes place. Okay, so another droplet, small droplets of, okay, particular liquid, okay, small droplets of particular liquid, we are mixing with, okay, another liquid. So in such case, what happening, sir? Emulsion is forming. Emulsion is forming. Generally, this emulsion is forming by the either, okay, partially miscible liquids or immiscible liquids also. Okay, so this is the very, very important point. Keep it in your mind. Generally, these are of two types. Emulsions are two types, sir. What are that, sir? Oil in water type. Okay, so first of all, I will write oil in water type. Okay, second one, water in oil type. These are two types. Okay, these are of how many types, sir? Two types. See, first one I am going to talk about that one. First one, oil. Okay, dispersed in. Okay, oils dispersed in water. Dispersed in water. In water. This is one type. It is also called as O by W type. Okay, this is one type of emulsion. See, in this case, what happens, sir? I will tell. Okay, in this case, I am going to writing. Okay, so in this system, simple thing I will tell you. What is the oils dispersed in water? Okay, here oils acts as, in this case, acts as dispersed phase. Okay, dP. And water acts as, okay, water acts as dm, dispersion medium. See, dispersed phase, here dispersed phase is what, sir? Oil, and dispersion medium is what, sir? Okay, water, sir. So now how these are forming. Okay, see here one thing, example I am telling, simple example for this case. For example, milk. It is a example of oil in water type. What happening, sir? Tell me. Okay, see, I will discuss this thing. In a milk, what happening, sir? In a water, okay, small droplets or tiny droplets of, okay, liquid fat. What happening in this case? Tiny droplets of liquid fat, okay, fat dispersed in water. Okay, so in a water, what happening? Tiny droplets of liquid fat is, okay, dispersed, or okay, droplets of, okay, liquid, tiny droplets of liquid fat dispersed in water. Then what is forming, sir? Milk is forming. See, that's why only from milk we are going to separating butter. Assimilate or not? The butter fat particles are nothing but the fat. Are you getting my point? So next, second type. Okay, second type, what is there, sir? For example, I am taking, okay, oils dispersed in water is, this is the first type. Okay, water dispersed in oil. Okay, water dispersed, okay, dispersed in, okay, in oil. This is the another type. This is called as, okay, W by O type. Okay, W by O type. Okay, water in oil type. See, in this case, what happening, sir? See, in this case, water acts as a dispersed phase. See, water acts as a dispersed phase. Water acts as dP and what is that next one? Okay, oil acts as dm, dispersion medium. Are you getting my point? What happening in this case? We'll come to this point here. See here, example I am going to talk about. I am going to talk about the example that is nothing but the butter. Okay, or cream. Okay, creams and butters. In the butter, what happening, sir? okay, tiny particles of water molecules, okay, tiny particles of water molecules, less quantity. What is the less, sir? Water is the less, okay, so that's why butter is in the semi-solid, semi-retardant. So tiny particles of water molecules, okay, water, okay, dispersed in oil is semi-retardant. So in this case it's forming. Examples what, sir? Butter and cream, the examples of this one. So generally I am going to talk about another thing, okay, butter, cream, grease also, okay, grease also comes under, okay, in this case, okay. See, I am going to talk about the next one. Generally, so emulsion, when we are going to making the emulsion, so these are unstabilized, okay, so we are using the third, okay, for the emulsification, okay. See here, I am writing the third substance is adding to stabilize emulsion, okay. These are called as, okay, emulsifying agents or emulsifiers. These are called as what, sir? Emulsifying agents or emulsifiers, okay. Fine agents. Why, sir? Because see, here I told you clearly, the emulsion is forming of two different type of compounds. One is the polar, one is the non-polar. See here, dispersed. For example, in the case of water, polar, okay, oil is the non-polar fat. Okay, these are immiscible each other. Then what happening? Droplets can be, whatever it may be, droplets can be settled down. So that's why we want to stabilize. So for the stabilization of these emulsions, okay, we are adding the third substance. The third substance is called as a stabilizer. Okay, means emulsifying agents or emulsifiers. These are called as a emulsifying agents or emulsifiers. Generally, emulsifying agents or emulsifiers are nothing but some particular ions are there. Some particular ions, and like lyophilic. Otherwise, simple thing will say soap, okay, synthetic detergents, okay. We may call this a hydrophilic colloids also, protein, gum, okay, agar. These are all the emulsifying agents or emulsifiers we are using generally, okay.